So with these geometric shapes and formulas, I'm not really doing a lot of examples here, but it's important that you understand what the words mean, what the figures are, what they look like, understand the formula, the units of measure, that type of thing. So I'm mostly just explaining. When you actually plug in the numbers, it's just going to be you and your calculator doing these multiplication problems. Okay, so we can have a square or a rectangle. The formula is the same. The only thing that's different is a square, the way, this side is the same as this side. Sometimes they'll use an S and they'll put, oh, the area of a square is S squared. So, which makes sense. You'll see that formula sometimes, but you can just think of it as length times width as well. So like for a rectangle, a square is just a special rectangle. So we have usually I make the width the shorter one and the length the longer one. And so we're just multiplying. Again, these are both going to be measured in square units. So maybe feet squared or inches squared, something like that. Volume, then that's the capacity, how much a box holds. Now, it's called a rectangular solid or a rectangular prism. But you can just say box. So that's probably what they call it, a lot of people. Okay, and then we just take the length times the width times the height. We make sure the units are the same on all of them. And then this is going to be measured in cubic units. So maybe feet cubed, maybe inches cubed. Okay? Now, the parallelogram. The definition of a parallelogram is you have two sides, opposite sides, that are parallel, and the other two sides are also parallel. It has to be what we call a quadrilateral. It has to have four sides, okay? But they don't make right angles. That's the difference between a rectangle and a parallelogram. So these are not right angles. Not right angles. Again, you could say, well, a rectangle is just a special parallelogram. Okay, so think of it as a box, but then it's just been like shifted, okay? So the formula is the same as like a rectangle. Length times width. They put width times length, but that's okay. Well, how do you measure the width? The width, let me do this. The width is going to be the distance between two parallel sides, okay? And then the length is going to be this distance for the sides that you're measuring between for the width, okay? So that probably sounds a little more complicated than it is, but maybe the picture helps. Okay, so you have to make sure you get the right measurement for the width. It is not this distance here. That would be different, right? So you're just measuring this perpendicular to the two lengths. Okay, that's the width. Okay, and then the two that you're going between, the widths between, that's the length. Okay, now hopefully that makes sense. Okay, now here it is in, oh, again, this is going to be a square measurement, like square feet or square meters. Okay. Volume, that's going to be just like you have your box, but now the box, it's a cardboard box, and it's tilted. There's nothing inside it, right? So like here's the cardboard box, and then it's just kind of like leaning over. So you still have like a width, a length. It's, the same measurements here as if you were to put it right side up, okay? It doesn't matter really which one's which. Now, when you do that, though, for this, you're going to have to go again between these two to get that width measurement. So you could think of, just like we thought of the stacks of Oreos and the stacks of Townhouse crackers, think of like a square cracker, and then, like a saltine, and then you're multiplying that area of the square times that length, okay? Now, the same thing is, I can't think of a triangular cracker, a parallelogram cracker, but if you had parallelogram crackers, it would be a stack of those. So you're finding this area of the front cracker, and then you're multiplying it times the length, how long that package of crackers is. Okay?